This is Physics for Grade 9, produced by Tigray Education Bureau, transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media, and also FM Maqala 104.4.
Hello students, welcome to today's lesson. Today's lesson is fluid statistics. Before we learn fluid statistics, let me remind you the previous lesson. I hope you have discussed about simple machines. Let me remind you the main points of simple machines. Simple machines are designed and engineered to simplify our mechanical work. The purpose of simple machines are to multiply the force applied on them, to multiply the speed or distance, to change the direction of the applied force. You have learned these pointers from the previous lesson. Today, we will learn about fluid statics. Fluid is a substance that can flow. Fluids are either liquids or gases. Because liquids and gases can flow. Flow means the smooth, unbroken movement of substance. Let's see the concept of pressure. Pressure is the amount of force acting per unit area. It is a scalar physical quantity. It doesn't depend on direction when we want to add or subtract it. It is a derived physical quantity. Its SI unit is Pascal. There are non-SI units for pressure, like millimeter mercury, bar, millibar, torr, atmosphere, etc. 1 Pascal is equal to 1 Newton per meter square. It is calculated as pressure is equal to force over area. Its dimension is ml the power of -1 t the power of -2. It depends on 1 the force applied, 2 the area in contact. Students, let me give you one example. A 100 Newton force is applied on the area of 2 meter square. Determine the pressure exerted on it. Listen to the answer. Pressure is equal to force over area. Force is 100 Newton and area is 2 meters square. So 100 Newton divided by 2 meters square is equal to 50 Newton per meter square, or 50 Pascal. The greater the force applied, the greater the pressure. The larger the area, the smaller the pressure exerted. Because pressure is directly proportional with the force applied on it and inversely proportional to the area in contact. Students, are you with me? All right. If you are with me, please do this question. What are the factors that affect pressure? If your answer is force and area, you are correct. Our next topic is atmospheric pressure. Atmosphere is the layer of air that surrounds the Earth. Atmospheric pressure, the force per unit area exerted against a surface by the weight of the air above that surface. 1 atmospheric pressure is equal to 101 kilopascal is equal to 760 millimeter mercury. This value of pressure is observed at sea level. Atmospheric pressure depends on altitude. As altitude increases, atmospheric pressure decreases. If you go up and reach the outer layer of the atmosphere, the pressure decreases until it reaches 0. If you go up and reach the outer surface of the atmosphere, the pressure decreases until it reaches 0. Low pressure areas have less atmospheric pressure above the location, whereas high pressure areas have more atmospheric mass above their location. Well, students, have you understood? Let me ask you one question and ready to answer it. What is the relation between altitude and atmospheric pressure? Alright, if you say the relation is inversely proportional, you are correct. Our next topic is measuring atmospheric pressure. Students, how do you measure atmospheric pressure? Listen to me. Atmospheric pressure is measured by an instrument called barometer. There are different types of barometers. Some of them are listed below: mercury barometer, aneroid barometer, water barometer, alcohol barometer, etc. Let me start from the mercury barometer. Mercury barometer is a glass tube completely filled with clean dry mercury. Mercury is selected for constructing a barometer due to the following advantages. 1. It is denser. 2. Relatively short column. 3. It is easy to see because it is colorful. 4. It does not freeze in a very cool weather. The next one is aneroid barometer. Aneroid barometer is a device for measuring atmospheric pressure that uses a corrugated metal box rather than liquid. Aneroid means without liquid. Students, try to answer this question, please. Why mercury is selected to constructing barometer? I hope your answer is it is denser, relatively short column, it is easier to see, it doesn't freeze in a very cool weather. Alright students, our next subtopic is application of atmospheric pressure. Atmospheric pressure has many applications in day-to-day life experiences. Those applications are due to the pressure difference. Pressure difference is the relative value of the pressure of gas in different chambers. Some of the applications of atmospheric pressure are common pump, syringe, lift pump, drinking straw, suction pad, force pump, siphon, etc. Let us see them one by one. The first one is common pump. It is a pump that relies on atmospheric pressure to move water. It has two valves, one on the piston and the other at the bottom of the barrel. The second one is syringe. It is used by doctors and nurses to give injection. It consists of a tightly fitted piston in a barrel. The syringe applied due to the atmospheric pressure that helps to put into it. And the third one is drinking straw. It is a thin tube used to suck liquids into the mouth. Example, when you drink a juice, you may use this material. The fourth one is suction pad. It is a round rubber pad. It is used for attaching pictures on shops and car windows. Or it is used to stack pictures onto smooth surfaces. The fifth one is force pump. It is a pump that relies on atmospheric pressure and compressed air to move water, often from underground to the surface. The last one is siphon. Siphon is a device that transfers liquid from higher level to a lower level, or is a convenient way of removing liquids from a container, like aquarium, petrol tank. It can't work in a vacuum. It must fill it in a liquid. Students, please list the 6 applications of atmospheric pressure. I hope your answer is common pump, syringe, drinking straw, suction pad, force pump, siphon. Student, our next topic is fluid pressure. A state can exist in solid, liquid, or gas. Solid states have definite shape and volume. They have high density than liquids and gases. The particles are very close to each other. They have a strong bond between their particles. The next one is liquid states. Liquid states have no definite shape. They take the shape of their container. They have definite volume, mass, and weight. When we compare to molecules of solids, the molecules of liquids are relatively free to move. Liquids' densities are smaller than the solids' density. They are incompressible. They have a weak bond between their particles. The next one is gases. Gases have no definite shape and volume. They take the shape of their container. They have mass and weight. gas molecules are free to move. They have the lowest density compared to liquids and solids. They have no bond between their particles. They are compressible. Now, we will see about fluid density. Density is the mass per unit volume of a substance. It is a scalar physical quantity. It is derived physical quantity. Its SI unit is kilogram per meter cube. 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Its dimension is ml the power of minus 3. It is symbolized by a Greek letter rho. It is calculated as rho is equal to mass over volume. Students, our next topic is relative density. Relative density is the relation between the density of two substances. It is a dimensionless physical quantity. Its formula is relative density is equal to density of substance over density of water. Students, I will give you an example. Example, determine the relative velocity of alcohol that has the density of 800 kilogram per meter cube. Students, let's list the givens. Given, density of water is equal to 1000 kilogram per meter cube. Density of alcohol is equal to 800 kilogram per meter cube. Under the required one, what is the relative density of alcohol? Solution. Relative density of alcohol is equal to density of substance over density of water. Density of alcohol is 800 kilogram per meter cube over 1000 kilogram per meter cube. By simplifying the calculation, the answer will be 0.8. Assignment. Students, it is expected from you to prepare number 1. Prepare your short note from page 156 to 176 of your textbook. Number 2, to do all the activities in chapter 6. Till next week, goodbye.